Okay, since x is not by itself, or y, if y or x were by themselves, I would use the substitution method, but because x and y aren't by themselves, I'm going to use the addition method. And for me to be able to use the addition method, either the variables or either the coefficients next to x or the coefficients next to y have to be the same. Well, here, as you can see, the coefficients next to y, or the coefficients of y, are the same. Now, not only do the coefficients of the variables have to be the same, but the signs have to be different. So remember that. Coefficients the same, signs different. But as you can see, the signs aren't different here. So I'm going to make one of the signs a negative by multiplying everything by a negative. So if I multiply the bottom equation by a negative, that gives me a negative 4x, a negative 7y, and a negative 40. Okay, so now I can combine these equations, and a negative 8 and a negative 4 give me a negative 12x. These cancel out because a negative 7y and a positive 7y equals 0. And then I'm going to combine the 40 and the 4. Well, since the signs are different, right? Positive, negative, signs are different. I'm going to subtract, and the sign of my answer is going to be the sign of the bigger number. So since the sign of the bigger number was negative, that's going to be the sign of my answer. Now, when you have negative on both sides of the equation, like we do here, it just automatically turns into a positive. All right? And then once I get to this point, to solve for x, since this is 12 times x, I do the opposite operation, which is division, right? So I'm going to divide by 12. But what I do to one side, I have to do to the other, so I'm going to divide the other side by 12. The 12s here kind of cancel out. Really, it equals 1, and 1 times x equals x. But I just cancel them out. And then 36 divided by 12 is 3, because 12 times 3 equals 36. Okay? That's my answer for the first equation. Let's go to the next one. Here again, we have x by itself without a variable, so I could use substitution, but since I also have a 2y, a positive 2y, and a negative 2y, the easiest thing to do is just to cancel these out, right? Because the variable is the same and the signs are different, so I'll just cancel that out and add these two x's, that gives me 2x, and subtract the 15 minus 9, that's going to give me 6, because when I add 6 to 9, I get 15. And now when I get to this point, I do the opposite operation. This is 2 times x, so I'm going to divide, because the opposite of multiplication is division. I'm going to divide both sides by 2, so I get x equals 3. That's the answer for that equation. Here I'm going to use substitution. I could use addition or substitution. Well, here I'm going to use substitution. I'm going to add 4y to this side to get x by itself. Now I'm going to add 4y to this side. So now I have x by itself. X equals 3 plus 4y. So since x is the same as 3 plus 4y, wherever I see 3 plus 4y, wherever I see x in the other equation, which is here, I'm going to substitute it for 3 plus 4y, since x is the same as 3 plus 4y. So 3 times, instead of writing x, I'm going to write 3 plus 4y, parentheses, minus 8y equals 10. 3 times 3 is 9. 3 times 4 is 12y minus 8y equals 10. Remember, whenever you have a number in front of the parentheses, you multiply that number times everything inside the parentheses. That's called the distributive axiom, or the distributive property. You distribute the 3 with the 2 numbers inside the parentheses. Now I'm going to combine like terms on both sides of the equation. So 9, and since these y's are the same, I could add the 12 and the 8, or combine the 12 and the 8. 12 minus 8 is 4, and since the bigger number is positive, I know the 4 is going to be positive, so I get 4y equals 10. And then my goal is to get y by itself, right, to isolate the variable. So to do that, I've got to get rid of this 9. Well, since this 9 is a positive 9, and I know it's positive because there's no sign in front of the number, and when there's no sign, it's positive, I'm going to subtract 9 from both sides. What I get is 4y equals 10 minus 9 is 1. And this means 4 times y, so I'm going to divide by 4 to get rid of the 4 on both sides. So I get y equals 1 over 4. So now I know what y is, so I'm going to plug it back into my equation here. Since I know what y is, I'm going to plug it back into my equation here to solve what x is. So x minus 4 times 1 over 4 equals 3. X minus 4 over 4, because 4 times 1 is 4, so I get 4 over 4 equals 3. And then x minus 1 equals 3. And then I'm going to add 1 here, so I get x, so this equals 0, plus 1 and minus 1 equals 0, x equals 3. Okay, so x equals 3 and y equals 1 over 4. And I didn't solve what y is in this equation up here, but you should be able to do it by just plugging in for the number for x into either of the equations and solving for y. Same with this one, just plug in x into either one of these equations and solve for y to get what y equals. Okay. Again here, I could either use substitution or addition. Since we have the two letters the same, I'm going to use addition. So I'm going to turn this into a negative by multiplying everything by a negative, right? If I multiply every term by a negative, the equation stays the same and I can solve using substitution, using addition. I'm going to use addition. So a negative y and a plus y cancel out. Negative x plus 2x equals just x, because if I have 2x minus x, I get just 1x, right? And then 6 minus 5 is 1. I know I have to subtract because the signs are different. This is a positive and that's negative. That automatically tells me I have to subtract. And since my bigger number is positive, the sign of my answer is positive. So x equals 1. Now that I know what x equals, I could plug it into any of these two equations and solve for y. And I think that's it.